The Pendulum Simulation is an interactive educational tool designed to help students explore the principles of periodic motion, specifically the behavior of pendulums under various conditions. By providing a hands-on approach to investigating the factors that affect the motion of a pendulum, the simulation offers a comprehensive learning experience that covers key concepts in physics. The simulation allows students to use controls to simulate pendulums with different lengths, angles, and gravities, providing insights into the dynamics of periodic motion. Periodic motion refers to a motion that is regular and repeating in equal intervals of time. Examples of periodic motion include the swinging of a pendulum, the vibrations of a tuning fork, and the revolutions of the Earth around the Sun. The pendulum simulation begins by introducing the concept of periodic motion, explaining how it is characterized by regular, repeating cycles. The simulation provides an interactive platform where students can actively engage with the concept of periodic motion. By using controls to simulate pendulums with different lengths, angles, and gravities, students can gain a deeper understanding of the principles governing the motion of pendulums. This hands-on approach helps students grasp the complex and fascinating world of periodic motion. The pendulum simulation allows students to explore how the length of the pendulum affects its motion. By adjusting the length of the pendulum using the controls, students can observe how the period of the pendulum's swing changes. The period of a pendulum is the time it takes to complete one full cycle of swinging back and forth. The simulation helps students understand that the period of a pendulum is directly proportional to the square root of its length. The simulation also allows students to explore how the angle of displacement affects the motion of the pendulum. By adjusting the angle at which the pendulum is released, students can observe how the amplitude of the swing changes. The amplitude is the maximum displacement of the pendulum from its equilibrium position. By observing the relationship between the angle of displacement and the amplitude, students can gain insights into the principles governing the motion of pendulums. The pendulum simulation enables students to explore how gravity affects the motion of the pendulum. By adjusting the gravitational force using the controls, students can observe how the period of the pendulum's swing changes. The period of a pendulum is inversely proportional to the square root of the gravitational acceleration. By exploring the relationship between gravity and the period of the pendulum, students can gain a deeper understanding of the principles governing the motion of pendulums in different gravitational environments. The simulation helps students understand the concept of simple harmonic motion, which is a specific type of periodic motion where the restoring force is directly proportional to the displacement from the equilibrium position. The motion of a pendulum can be approximated as simple harmonic motion for small angles of displacement. By observing the motion of the pendulum, students can see how the principles of simple harmonic motion apply to real-world scenarios. The pendulum simulation also introduces students to the applications of periodic motion in various fields. Periodic motion is fundamental to many areas of science and engineering, including mechanics, electronics, and astronomy. By understanding the principles governing the motion of pendulums, students can gain insights into the broader applications of periodic motion in the real world. The simulation provides an interactive platform where students can actively engage with the concept of periodic motion. By using controls to simulate pendulums with different lengths, angles, and gravities, students can gain a deeper understanding of the principles governing the motion of pendulums. The visual nature of the simulation makes abstract concepts more tangible. Students can observe the motion of the pendulum, the relationship between the length, angle, and gravity, and the principles of periodic motion in real time, helping them to grasp complex ideas more easily. The simulation offers immediate feedback, allowing students to see the results of their adjustments instantly. This helps correct misunderstandings quickly and reinforces learning through trial and error. The pendulum simulation is a valuable tool for teaching and learning about the principles of periodic motion and the behavior of pendulums under various conditions. By providing an interactive, visual, and comprehensive platform, it helps students understand the factors that affect the motion of a pendulum, including its length, angle of displacement, and gravity. The simulation allows students to use controls to simulate pendulums with different parameters, providing insights into the dynamics of periodic motion. Whether used in a classroom setting or for individual study, this simulation can significantly enhance the learning experience and build a strong foundation in physics. Through exploration and experimentation, students can gain a deeper appreciation for the complex and fascinating world of periodic motion and its applications in various scientific and engineering fields.